Hello again, everybody, and welcome back to another day of Math 7. I hope everybody had a wonderful spring break and a happy Easter. So let's get going here. So for those of us who noticed that on Canvas there's no 612 and we skipped right to 613, that was on purpose. I don't think 612 is really that important since we're on crunch time kind of before SOL gets here. So we're just skipping that and going directly to 613 today. So, we are going to take a look at graphing linear relationships and determining the rate of change. So, how can we tell if a situation is proportional? So, there's many different ways, remember. So, if the information is on a graph, then the line will always pass through the origin. We talk about that a lot. If the line passes through the origin, it is proportional. If the information is presented in a table, we check the proportionality by doing the cross product. Or we've also been calling that the butterfly method. If the two cross products are equal, then we know that it's good to go. So if we are given the points on a line, then we can compare each point with the ratio y divided by x. Always y divided by x. All right, so the ratios, we can also call that the rate of change, the slope, and we've also called that m. All three of those are the same thing. So all three of those will be the same for each point, the rate of change, the slope, or m. All right. So now we're going to take a look at the following and we're going to say yes or no. Are these proportional? So number one, it's a graph, so we're going to look up to number one here. So take a second, think to yourself if it's proportional or not, and then we are going to take a look at it. So does this line pass through the origin? Well, our origin on the graph is right here, and our line is shifted up and away from it. So pretty easy to tell that no, this will not be proportional. Alrighty. Now, number two, we are given it in a table. So we're going to call miles our y and our hours our x. So we are doing y divided by x here, just like number 2 up here tells us to do. So 110 divided by 2 is 55. 275 divided by 5. Let me just double check. And sure enough, that's 55. These are getting a little bit bigger, so I'm going to pull out a calculator real quick. Give me a second. You may use a calculator on this. Alright, so we've got 495 divided by 9, which is 55. We always want to be sure that we double check all of these, just in case. 770 divided by 14 is 55. Because we want to check all of them because they could give you the same thing for the first, second, and third, and then they'll throw one at you where the ratio is 50 instead of 55. So always double check all of them. But in this case, they are all the same, y divided by x, so we are going to say yes. This is proportional. Now, when we're given these brackets with a bunch of different points, so this is like number 3, we have sets of points on the line. So remember, the second number is always y, and the first is x. So we're comparing that ratio here. So negative 12 divided by negative 2 is 6. 24 divided by 4 is 6. And 36 divided by 6 is 6. So, yes, these are proportional, these points. All right. Now, just a quick reminder. The unit rate, or we call that unit price if we're dealing with money, is the rate per one unit or one item. So how much does one of these items cost if you get certain price for so many of them? So we find the unit price by dividing the total price by the number of units. So their example here says $25 for 5 toys. They're going to take their $25 and divide it by the 5 toys, and they'll get $5 for every 1 toy. So stores are able to make a profit by buying in bulk. This means that they buy a lot of something at one time and they get a discount on it. So they are charged less per item because they agree to buy a large number of that item. So when the unit price of a bulk item is less than the unit price for a small order, then the rates are non-proportional. So if they have to charge a little bit more when you buy less, then it's non-proportional. So we're going to try this down below for each exercise. So the number of units and the total cost is given to us. We want to compare column A and column B to see if these are proportional or not. So 100 t-shirts printed for $428. This is going to be $4.28 per shirt. Pretty quick there. We can just, since we're dividing by the number of shirts, we can just move our decimal twice since we're dividing by 100. Not so easy for column B. So what we're going to do is just go ahead and use a calculator to do this. So $12,180 divided by 3,000 shirts is going to be $4.06. So they got a discount for buying in bulk, so this is a non-proportional relationship. All right, so the numbers are not easy to do for this second one here, so we are going to take our $43.20 and divide that by the 8 books that we bought. And we get $5.40 per book. Now we're going to compare column B. We paid $1,350 for 250 books. So we will divide that out and we get $5.40 per book. So this is a proportional relationship because our unit prices were the same for both. If the unit prices are different, then it's non-proportional. All right, and finally, on our quick review here, so we're going to investigate this graph here, water usage over a certain amount of time. So is this proportional or non-proportional? So hopefully you can take a look at this really quickly and think in your head before I tell you. If you guessed proportional, then you are good to go. It crosses through the origin, so it is proportional. Is this an additive or multiplicative relationship? Well, if we remember, if it's proportional, then one of these it is always and another it is never. So a proportional relationship can never be additive. So if you said multiplicative, you are correct. Only multiplicative relationships are proportional. So what is the rate of change, or our slope? So remember, pick 2 points. I'm going to say this guy and this guy. So what is our rise? Remember, rise over run is slope. So we want to count from point to point. So moving from here, so this point here, we've got 1, 5, and then this point here, we've got 2 comma 10. So my rise, it looks like, is 5, and my run is 1. So 5 over 1 is my slope, which is just equal to 5. So m is our slope here. So what is the equation that represents this relationship? Well, remember, this is a y equals m times x format. So y equals, well, what did we just say our m was? We counted out our slope, our rise over run, and we got 5 times however many minutes will give us the total amount of water we've used. All right, so now we can use our equation to tell how much water we will use after any number of minutes we want. So x in this case now will be 55 minutes. So we're going to plug that in for our x, and 5 times 55 is going to give us 275 gallons we've used in 55 minutes. So 275, let's call that G for gallons. All right, so pretty quick review of some stuff we've been working on for the last few weeks here. So we get one of those rare opportunities today where our assignment does not begin on our notes page, so there's no problems on our assignment to get done here. So on the next page on Canvas, there will be the independent practice, so be sure you complete that on a separate piece of paper, take your photo, and submit it in the assignment turn-in spot. All right, as always, if you have any questions or concerns or issues with anything, then shoot me an email or a message on Canvas, and I will get back to you as soon as I can on either one of those. Thank you, and have a great day, and we'll talk to you on the next lesson. Bye-bye.